So welcome everybody, and thank you that so many could join us today. Also, we have a lot of people attending this webinar. And of course, some of you might have attended our first webinar about virtual testing, and there is a recording on the way. And this is session 2, where we'll dive more into the advanced use within virtual testing. And let's see. We have a short agenda here. We'll just do some introduction. We'll of course have the live demo. Don't worry, it's safe. There are experts in the room. We'll talk about a bit about the new Simulia brand and what you can do with advanced testing in that. And then we'll have questions and answers. And of course, feel free to ask any question you want during this session. I have my colleague Irene who will be taking care of questions, and she'll be answering them as fast as she can. And there will always also be a question and answer session in the end. And you have a small chat on the right in the dialogue where you can ask your question, and feel free to ask any question. Okay, my name is Igor Kavanagh. I'm a software specialist with the PLM Group in Denmark. I've been working with SolidWorks since 2000, the normal SolidWorks, simulation, PDM, 3D experience, and a lot of other cool tools that you have in the SolidWorks brand. I was a SolidWorks Elite Application Engineer in 2009. I was born in '61. I'm married, have 3 children, and I live in Hillerød in Denmark. And I'm very proud to welcome again our guest speaker, Mathias Robertsen, longtime SolidWorks simulation specialist with SolidWorks and virtual testing guru. So welcome, Mathias.
Thank you for inviting me. Glad to be here.
Yes. And we also have Irene Holmström from PLM Group in Norway, who will be taking care of the questions. So thank you for being here also, Irene. And of course, we have Anders Wenzel, the pole master and software specialist with PLM Group in Denmark, and our latest SolidWorks Elite Application Engineer. So congratulations, and thank you for being here also.
My pleasure.
And of course, we'll start with a small poll just to let's get acquainted and see who's joining us today. So, Anders.
Yes, exactly. Since we have a lot of attendees, we would like to get to know a little bit about you guys. So who's tuning in today? Are you in some kind of management? Are you in engineering, in IT, or something else? So if you would please take a few seconds to answer this poll real quick, then we'll have a look. I'll just give you 5 more seconds for this. And let's see. Well, just as the last one, we have a lot of engineering guys in our webinar today. That's nice. So a lot of users.
Nice. But everybody, please feel free to join in. So there is something for everybody in it. But of course, this is an engineering task.
Yes. And I have another. We would also like to know what your experience is using SolidWorks simulation software. So I have another one for you here. Would you rate yourself as a beginner, an average, advanced, or expert user? Last time we had a lot of beginners and average users. Perhaps it will be a bit different this time, but we'll see how it goes. Just a few more seconds. And let's have a look. So a bit more spread on the users, but still a lot of beginners. So that's nice. So we can have a look at what we can offer you.
Yes, exactly. It's nice to see so many beginners still joining on our second advanced. So there should be a lot of cool stuff that you can look at it anyway. And of course, we also have something for the average and advanced, and even the experts should find something nice today. So if we take a look at our first session, our first webinar, we saw how the simulation has evolved through the years, and Mathias took us down the history lane, and we was checking how you can test a product strength in 5 simple steps with virtual testing in SolidWorks, and that you can test the durability to secure a better outcome, and you might want to build in a weakness in order to secure your product and secure your design. And also that the topology study, which is one of the new cool features that you have in SOLIDWORKS simulation, that you can use it not only to improve your design, but also reduce the material use and cut the costs. And you can do that all at the same time. So in this second webinar, we'll be doing some more advanced virtual testing. So we'll have a brief summary again of all the cool tools you have with virtual testing in SOLIDWORKS and on the 3D Experience platform. We'll do a short demo of the fatigue, the fact that the material deteriorates if you have vibration, and that is as easy as you riding your bike. We'll have some virtual testing. You can do it on the desktop or the platform, and you can do both. And of course, we'll dive into the more advanced testing options that you get on the 3D Experience platform with the Simulia brand, because the future is now. So first of all, what can you test? Well, as we saw, there are two offerings. There is the, let's see, my mouse working? Yes, now it's working. There are the desktop options that you have with the SOLIDWORKS built on top of SOLIDWORKS. So you're working within your normal SOLIDWORKS with the desktop options. And you, of course, have the new cloud options with the 3D Experience platform and the Simulia. So if we dive into what you can actually do there, we have the simulation standard. First of all, where you can do linear statics, that some of you might be acquainted with already. We have the simulation professional, where you get a whole lot of tools that you can use to do topology, buckling, frequency, 2D mesh. You can do optimization of your model. You can do thermal studies, drop test. You can divide it into a submodel to do a more refined calculation. We have fatigue that we'll do a bit more of today. We have a material library, extensive material library, where you have all sorts of materials that are tested and certified that you can download and use for free. We have more advanced motion, and you can do pressure vessel and load case manager, where you can combine different types of loads and put them in together and find out where you have your maximum stresses. Then we have the simulation premium. And with simulation premium, you can do dynamics. So that's a shock impact. You can do random vibration. We have non-linear materials where you have materials like rubber that you can test. You can go beyond the yielding point and all the way to the ultimate strength and test that also. And you can have deformations that will not go away when you release your product also. So you can do a lot of more testing there. We also have a composite materials that you can use in simulation premium. So we have carbon fiber and other sorts of fibers, laminate and glass fiber that you can use. Then we have the second brand, which is injection molding, where you can check your plastic molds and you can check it for the filling time and the cycle time and what the temperatures are like, whether that's feasible. You can check sinkholes and runners and air traps and weld lines and stuff like that to make sure that your design of your cavity and your plastic design is okay before you started building a very expensive mold. We also down at the bottom have the flow simulation, where you can do flow of gases and liquids, and you can do them internally or externally, and you can check the turbulence and mixing temperature. You can check pressure drops in your models. There is an electronic cooling add-on, so you can check stuff like heatsink design of electronics. And there's an HVAC module where you can test the temperature and the comfort of people in a room. So you can check sunlight, you can check computers dissipating heat. You can check the ventilation system, and you can make sure that everybody is working or staying in a comfortable room. And you can also check if you have some sort of pollutant, whether it is within the safety limits of the specifications you want. So we also have the Simulia brand that we'll dive more into today with the structural performance engineer, where you can do advanced nonlinear, and structural mechanics engineer, where you're able to set up more advanced studies, and you have a whole different lot of cool tools that you can use to design your products. And there's also some standalone products that actually run on the desktop with the Xflow CST study and the full Abacus. The Simulia brand is based on the Abacus solver. And the CST study you can use to create electromagnetic interference simulation. And with the Xflow, it is flow just like SolidWorks flow, but you can do more advanced studies with particles and more advanced stuff. And I know, Matthias, that you'll be getting more into this a little bit later.
Yeah, and as you can see, we have a lot of simulation technology today, even before, and more is coming also. So we're quite glad to have more simulation tools to work with. So we go through them.
Yes. And one other cool thing about this is actually that you're used to with SolidWorks that you buy a perpetual license, so you buy the SolidWorks simulation and you have it forever. If you have some needs for a shorter period to do some calculations, you can actually rent it for 3 or 12 months on a term license and get the more advanced functionality when you need it. And when you don't need it, you don't have to pay for it anymore. So that's one of the new cool features you also have with the simulation. And in our last webinar, we was taking a look at the virtual testing areas we have, where you can actually test your different materials, so you can identify the forces and loads, and you can make sure that you build your model to last. You can maximize the strength and stiffness, do factor of safety and verify connectors, and do vibration loading and all sort of stuff. So this is something that you can really do with the new advanced stuff. But let's see, we would like to ask you a few questions again and how you do your design now. So Anders, do you have a poll?
Yes, I have a quick one here. So before jumping into the examples, we would like to know how you are verifying your designs in your company at the moment. So are you actually verifying them? Are you perhaps using hand calculations? Are you building physical prototypes, perhaps through 3D printing? Are you using some sort of virtual testing software, or are you doing something else? So if you take a few seconds to answer this. Last time we had a lot of you people making physical prototypes, and I can see a trend again this time. So in just a few seconds, I will make the big reveal. And let's have a look. Still, we have a lot of physical prototypes here, but a few more of you are actually using virtual testing software, so that's great. Let's see if when this webinar is over that we can have even more of you using simulation. But with that, let's jump back to you, Ivar. I think it's demo time.
Oh yes, we have prepared a short demo, and some of you might recall, if you joined our first webinar, we had a demo with an airplane wing, where we saw that when you are designing airplane engines and wings, you attach them together with a small bolt connection, so that you are sure that if the engine fails, then you will not have a plane wing that crashes, so that you can land safely. And we were talking about the Denver plane engine failure back in February 21, where the engine failed, as you can see in the pictures, but the plane landed safely and nobody got hurt. It actually turned out that the reason why this plane was failing was due to fatigue. So the problem with vibrating parts that deteriorated its strength over time. So let's take a look at that. And of course, this was due to failing maintenance of the airplane, probably. So we'll not look at an airplane, we'll look at a bicycle design. So when you are on your bike riding and you are high up in the air, when you land, you want your pedals and your crank to last. And they'll take a lot of vibration also, because you'll be loading and unloading it when you are pedaling. And actually, that is one of the parts that often breaks on a bike, as you can see on these examples. So it's quite common that you have a break because of fatigue on your bicycle. So we want to make sure that that problem does not happen with our new design. So let's see if we can get, yes. here we have it. So when you're loading and unloading your pedal, the material will fatigue over time, so it will have less and less strength over time, depending on the number of cycles that you are loading and unloading. So in this example, we asked our engineers to come up with some new cool designs that we could use. And they came up with 3 different designs. And of course, it should meet the specifications for the maximum load, so that should be within the range. But we want to take a look at how it fares with the fatigue for these 3. And it's very hard to see just on the models which one would go better with fatigue and which one we should not use. So we set up a study with a pedal loading of 300 pounds, good solid American, and we want this to last at least 7 million cycles. So how do you set that up in SolidWorks? Well, we have our SolidWorks here, and we put on the load of 300 pounds, and this is crank design example number 1. So we first do a static study. I'll just do it very fast. Here, as you can see, we put on the load of 300 pounds. And if we just take a quick look at the Phronesis, you can see that it's max 232. We're using some aluminum that can take 275, aluminum 6061, so that should be okay. So let's dive into a fatigue study. So we just create a fatigue study from the existing and do a normal loading, unloading type. And then we'll add an event saying, well, we want our static loading to last for 7 million cycles. And we don't want to do fully reversed because then it would be plus minus 300 pounds. We'll just load it from 0 and up to max, but do that 7 million times. And then we'll take a look at number 1 and do a calculation of that. Well, let's just check the material first, because of course, in order to calculate fatigue, you'll need to have a fatigue curve, and that's been put in here. So you can see the number of cycles, and you can see the material maximum Phronesis. It went from 300 to 71. And if we do a quick calculation, we can see that the damage of this one, there are some problems there in the middle, and we can also see that the resulting life in the red areas, it will not last for the full 7 million cycles. So crank design number 1 seems that it's not good enough to do the 7 million cycles. So let's see what happens in the next cycles. So here we have design number 1, and that actually only lasted for 1.5 million before it would break due to fatigue. Design number 2 looks a bit better because that takes 8.8 million, and we had the 7 million as our target, so that looks very nice. But what about the design number 3? That only lasts 500,000 cycles before it starts cracking. And you can see that the fatigue cracks are actually in a quite different place. So you cannot from the beginning see on your design where your fatigue problem might come. Of course, it's usually around some of the max stresses, but you can never be sure about that. So number 3 didn't work either. So if we take a look at the design number 2, the one in the middle, you can see that the maximum stress is quite low, 196 compared to the 275 that the aluminum 6061 can take. We have a factor of safety of 121. And we can see that we actually have a quite high deflection of 3.26, while design number 3 only had a deflection of 1.49. So it's a more stiff design number 3, but still not within our specifications. We can also check the weight and see that it's around 400 grams, and that design number 1 was actually a bit lighter. So what we could do now that we have the correct design for our fatigue study was that we could take that to the topology that Matthias showed on the last webinar, and we could even optimize more to make sure that we still are within the 7 million cycles limit, but that we could save some weight too. So to make a quick conclusion, we can see that the crank design number 2 is the one that we'll go forward with, because that is within our specifications and it will last a long time compared to the 2 others. And this was done on the normal SolidWorks simulation. You can, of course, also use the platform now to do your calculations of fatigue. So you actually have the freedom to select any platform you want, the desktop or the 3DEXPERIENCE platform, if you want to do that. And of course, you can do lots of exciting and more advanced stuff with Simulia. So that brings me to you, Matthias. I know that you have brought a whole lot of interesting things that are only available with the new Simulia brand. So what is Simulia?
Yeah, so let's talk about this. We have a lot of new simulation technology, and that comes from the Simulia brand. That is a brand that only deals with simulation technology. We already have that in our simulation tools today, but let's talk about our new possibilities here. We are using the simulation part of the 3D experience platform. That is an infrastructure that Dassault is developing all new technology for. And it's not just for engineering simulation, that goes for the whole company. It could be legal, HR, finance, you name it. But let's talk about the simulation part that we use here. And it's cloud-based. That means that you can actually solve your calculations on the cloud and access more computing power on the cloud. So let's talk a little bit more about that in a moment. There's also an environment where you have very secure access to your data. It is very, very protected with encryption, and you can only see the data if you're invited to your environment. And it's an agile solution. That means that you can scale up and down your needs for a certain amount of time. So let's go into the details, what we can see here in this simulation area. So Eva talked about what we had in our simulation portfolio for the SOLIDWORKS environment, which is great. We can do a lot of cool engineering checks, and it's based on your SOLIDWORKS environment. Now with this Simulia role, it is connected to the cloud. It's based on the 3D experience platform. Of course, you use your SOLIDWORKS geometry and drive your geometry and design changes in SOLIDWORKS, but you run the simulation with the Simulia technology here. So what we can do is really take a step into a more larger problem and more complex physics. And I will show you some examples what we can do here. The engine behind the Simulia technology is Abacus. Maybe you have heard of Abacus. This is a Rolls-Royce engine of simulation software. And it's a good solution for any kind of industry. And it includes multi-physics. And you can do really complex simulation here, like a car crash where you have a lot of material deformation, a lot of changing geometry, very rapid impact here. And this is really good to solve this kind of problem. We have no chance of doing this in our SOLIDWORKS simulation tools. And also now with the cloud computing and very big performance gains, the solver is very, very fast. So what are the technical reasons you want to go for to step from the SOLIDWORKS simulation environment into the Simulia? Well, I have listed some examples here, technical reasons, and I'll highlight some of those in a minute here. But in the Simulia world, we have more elements types, more ways to mathematically define the geometry, and also have handle bigger mesh, bigger problems. And also, as we saw with the car crash, a lot of complex contacts can be very easily solved here, and also large deformation. So anything with the material behavior, we can capture this in a quite detailed way. And it's good for impacts or failure study, multi-physics. And you can also do sequences. So if you have a simulation that happens in different steps, we can easily set this up. It's a bit hard to do in SOLIDWORKS with a time scale here. So performance gain, bigger problem, and you can also capture the best practice. You can customize your user interface so other people really could follow the best practice how to solve your problem and customize that so it's even more easy to use. And I think one of the big value is the cloud computing. You can run problems up to 144 cores on the cloud. Buying a computer for that is quite expensive, but we have that on the cloud. Cloud computing comes as free. You can use up to 8 cores for free, and if you want to use more, you can purchase that computing power when you need to. on the cloud. So there's a scale there as well you can add. So let's go into some of the details what I just mentioned here. Let's talk about the elements types. So in SOLIDWORKS environment, we have the beam, shell, and tetra elements, which is great to capture any kind of geometry. The most common question we get in SOLIDWORKS simulation is, do you have hex or brick element? And the answer is no, we have that in the Simulia roles. What is good with the bricks element is they are quite stable elements. It could be very good use for deformations, large deformations, and when it's collapsing here, we also have surface hex mesh there and other variants of these kind of element types. We also have a bit different elements type called SPH, that's smoothed particle hydrodynamics, and actually can mimic water, in this case a snowball that is, I'm throwing it on my test dummy here. So a little bit more options to set up your problem there. So let's talk about complex contacts, especially if you have anything with plastic or rubber, I would say. You can very easily run into very complex contacts depending on how the rubber material is deforming and come in contact with itself, and you have friction and it can snap over, and it's a lot of complex physics that could happen during this event. And also in a drop test, or how many faces that come in contact with each other during a test. That we can very easily solve with the Abacus solver in a fast way. So let's see some other examples here. Impacts. You can slow down an impact and see things in slow motion as much as you like. So here I have a bullet that is quite rapid sequence, and I can slow down the time and really see what is happening here in detail. It could be for safety checks. If you have some collisions that you want to check, see how much energy is absorbed with objects that are colliding with each other. And also here we have a can here that's being pressed all together. A lot of complex contacts there, and this is quite actually fast to do. And this is the power of the Abacus solver there. So a lot of impacts and collisions good to solve. Also failure, we can set up as a setting that the material could break apart. And this is impossible to do in SOLIDWORKS simulation, but here we can capture the material behavior in a model to see the material breaks apart. It could be intentional, like the plastic bottle head we have here, and you want to understand how much force is needed to separate those parts, or rip a paper in a part here. So you have a good user experience and understand the consequence and the impact of a material that is failing at some point. So what we talked in the first webinar was a lot about linear material models. And I would say this is the majority for all mechanical engineers. I'm a mechanical engineer as a background, and we want to make a design safe. We want to be under the yield strength, and with a factor of safety depending on your industry or your product application there. But if you look at steel, for instance, we have much more happening after the linear period, the linear line here up to the yield strength point. If we're passing that, we have a permanent deformation. We have the ultimate strength and also the failure strength, where it actually breaks. And in SOLIDWORKS Simulation Premium, we can calculate permanent deformation, what is happening when we're passing the yield strength and so on. But it is very likely that more effects could happen when we are entering in the nonlinear area. For instance, the material could deform a lot, creating new contacts, metal hardening, temperature effects, and it's behaving as a very complex physics at this point, and also all the way up to the failure strength when we can see that it's breaking apart. And this is the power of Simulia to really capture this this process, these steps in a good way. And if you have any questions during this, so just type it in the chat. We will have a Q&A session very soon. If you have some question around this. So let's talk a bit more the material models. In SolidWorks simulation, we have a lot of non-linear material models that we can apply to our simulation. And in the Simulia world, we have even more. We also have the possibility to import test data. So if you have some data on an Excel sheet fresh from a machine, you can import and calibrate that to a material model. And here I have an example of some soft foam that is being pressed there. So it's really good to capture a correct material performance there. And what we talked about are some technology in the structural world. We also have fluids, we have plastics also on the 3Experience platform. And for the structural roles, we have different levels of capability and also ease of use, especially for the entry level that is more targeted for really new beginners or students. You have Simulation Express in every SolidWorks. I think this is a little bit more advanced, a little bit more capable than that. The next step will be the structural engineer. That is more what we have in SolidWorks Premium or the linear static. We have the hex elements here, so that starts to make a difference. And then we have the nonlinear and the more advanced physics, and we can use the cloud to solve our problem. So cloud is free. It comes up to 8 cores depending on the license. And then, as I said, you can acquire more computing power on the cloud if you need to. And then we have a role that can just look at the results if you want to. So that was a bit of an overview, a bit of a teaser of what we can do in the Simulia world with our new technology there, and more is coming.
Okay, thank you very much, Matthias. That's super exciting what can be done on the 3DEXPERIENCE platform with the new Simulia tools. But I think there's no doubt that for a very long period, we'll have the platform and the cloud coexisting, and the integration between the two will become more and more close. So it's really easier and easier for you to design your stuff in SolidWorks and export the information to the cloud and back. And you will be able to use whatever tools fits you best. So you'll be able to use the desktop if you want to do that. You can use the cloud. And I also think it's super cool that now you can actually do your cloud computing in the cloud. So you have the ability to do your calculation with the 8 cores that you get there. You can of course still use your desktop if you want to do that, even if you are calculating in the cloud. So thank you, Matthias. And I think we have some polls now. Anders?
Yes, thank you, Ivar and Matthias, for these great examples. We have 2 polls left for the day, and the first one is a quick yes or no question. Have we inspired you to start using simulation software in your company? Hopefully it will be a big yes. Otherwise we will have to do something else to convince you. But let's see here. I'll just close it. And a lot of you said yes. That's great.
Okay, that's very nice.
Yes. And the last one of the day, if you are not already using virtual software in your company, then how far are you in the process of implementing it? Are you ready? Would you like to learn more? Don't you know yet? Or are you not considering using this at the moment? I'll just give you 5 more seconds. And let's have a look. So a bit of a spread here. A lot of you would like to learn more, which is of course always available. Also in our Q&A session in just a few moments. And we have some people who are ready. That's very nice. So with that, over to you, Ivar, and let's wrap it up.
Thank you. Yes, it's great to see the big interest in simulation tools that we have, both on the platform and, of course, our good old desktop version also. So there are a lot of options, and of course, feel free to contact us if you need more information on the different options that we have. So I'll just do a quick summary. So today we have seen how easy it is to use the different engineering tools and that they're integrated in SOLIDWORKS. And you can, of course, use all of them to reduce your errors and your cost of your prototyping and your model. And you can use this to increase the performance and quality of your product, the virtual testing. Of course, physical testing is also very nice, but it's nice to get a good grip of where you are before you go to the physical testing. So all in all, the SOLIDWORKS simulation toolbox offers a lot of technology, as you have seen, and it's more than ever. And I know that the guys behind the technology are working super hard to get out even more cool stuff. So please stay tuned, because I know that we'll get a lot of new stuff coming and coming very fast. So you can use this technology to cover every design simulation possible, really. And it is a solution that contains a wide range of tools for various industries. So this allows you to design and develop more efficiently and cut down on your resources, and of course very easy to reduce the time to market your product. So that's very important. So, and what we all want to do, of course, is to design better products for our customers and for ourselves. So the final word of the day for this session is that SOLIDWORKS simulation is a way to work not harder, but to work smarter and more efficiently. So thank you very much. And now it's time for some questions, and feel free to ask any questions you like. We still have a lot of time. So over to you, Irene. Do we have some good questions?
Yes, thank you, Ivar, Mathias, and Anders. We have some questions, but feel free to write more if you have anything related to Simulia or more advanced simulation. So one of them, and this might be something more people are wondering about, is if there are SN curves or fatigue data available in SOLIDWORKS material database. And yes, it is for some of the materials. They will be marked with SN in parentheses. But if you have SOLIDWORKS Professional or Premium, you have access to the materiality database, and they have a lot more material with the fatigue data attached. Another question is if it's possible to save the ISO clipping plot shape in the 3D model. Do any of you have a good answer for that one? Because I'm not.
Yeah, exactly. That feature is not possible. That would be a good enhancement. There is a plot called Design Insight plot that overlays your existing design with a transparent results, and that is actually using the ISO clipping setting, so that you can overlay and use as a template to reduce material. So check that feature out, the Design Insight plot. That's the closest we can get at this
Yes.
question.
Yes, and of course you can always make your own special plot for that, and only have that in one of your plots. So you can add a new plot and just do the ISO clipping for that. But still, you'll not have the full 3D as you explained, Mathias.
One more question is about simulating cutting and drilling of materials, like a simple steel milling. And I would assume there is more a CAM feature, but maybe you can do it on Simulia, Mathias?
Yeah, that would be definitely for something for Simulia, if you want to see the chip and also the details of the tool itself, how it's going into material, and see how it's separating material there. Yeah, definitely something for Simulia there.
Mm-hmm. Can we use flow simulation and topology together to make the best shape for our aerodynamics? So you can take a flow simulation and implement the loads from that to normal study, but you can't run it together as one. Is that something you could do with Xflow, maybe?
Now, the close we get there is also we can drive SOLIDWORKS geometry from flow simulation result and do an optimization study. So yes, there are some tools, but it doesn't suggest a new shape. You're changing geometry and dimensions to find it, and it can do a lot of iteration, can do hundreds of flow studies and change it and tweak into an optimized geometry.
Yes, you can get the stresses from the flow simulation and put that on your model, and you can optimize your model with topology study according to that, and then you can rerun it. But you need to go through some steps to do that. So it's not directly integrated, but it is possible.
This topic is quite interesting. So there are some technology, we don't have that, but we are looking into do a more regenerative flow design also. So that kinds of, having a shape in a wind tunnel and start to remove and add material there also, but it is not fully developed.
It's some of the cool stuff that we should be looking out for, because more are to come.
Can you measure temperature rising of oil in an hydraulic system during hard run?
Is that possible in the Xflow, Matthias?
Yeah, I'm thinking of the physics of how it's been generated. It's been the friction between the oil and in the pipes. I think we need to follow up on that. I mean,
yes,
the temperature in general we can do, but depending on the movement, let's discuss this.
You're generating temperatures from the pressure of the oil. So the more pressure you have, the higher temperature you'll get from that. And I think the flow simulation in SOLIDWORKS cannot do that.
No, I don't think so either.
But we need to check the platform and see what we can do there.
Yeah, I mean, temperature in general, that's just a sign that if you know the temperature, but how it's generated. Yeah, let's follow up on that. Interesting question.
Yeah, very good question.
Yeah, very good questions today. There is something that wants more information of how the cutaway chips perform.
Okay.
The same guy with the drilling and milling material. Also,
Yeah,
there are some questions related to tutorials and whether it's free or not. It's not free software, and tutorials, if you want to trial, we'll have a discussion with you later. We'll notice your name and just let us know. Yes, I think that was most of the questions answered. So we still have some time. Are there any more questions or anything any of you guys would like to add? No?
There was one question coming in now.
Yeah, I saw it. That is very specific. If it is possible to simulate a complete test, for example, make a complete IPX8 test. I knew if you're familiar.
I don't know what IPX is. That the pressure and making sure watertight and so on. Let's look into the details on that. So generally, we want to mimic.
It's waterproof, I think. Yeah.
Yeah. Generally, we want to mimic physical prototyping and mirror that and do it virtually instead. So let's go into the details what that test is.
Yes. Quick guide to simulation. Yes, you will. I think they will get some information about this after the webinars when you have attended, won't they?
Yeah.
Yes,
Yeah.
yes. And also, there are actually some quick tutorials in SolidWorks simulation. So if you have simulation, you'll be able to go through them. So those are quick tutorials in order to get started with simulation and getting started with the different parts of simulation. Also, there are a different range of tools that you can use there to check the different parts of simulation, depending on which package you have.
Mhm. Yes. There are no more questions for now. Those of you who are asking more specific, we will get back to you. We have your names and
Yes, we'll get back to
details.
you, definitely.
Mhm. Okay.
Okay.
Yep.
So I think that just leaves the last slides. So thank you very much for joining. And Matthias, thank you very much for your time. Iron Anders, thank you for joining also. It's been super being together with you. So we'll see you out there, and please reach out if you have any more questions, and you have a great day wherever you are. So bye for now.
Thank you. Bye-bye.
Bye.
Thank you. Bye.